Okay, in this problem, we have a solid shaft fixed at C, and it's subjected to two torques as shown there. And I want to find the stress points A and B. Now, the equation that we're going to use for this, we'll start with B. We'll do B first. It's going to be, to find the shear stress, it's going to be the torque at B times C, which is basically the distance away from the center, usually the radius, which for B, it is the radius. It's on the outside of the object, all over J, which is the polar moment of inertia. So the first thing I need to do is I need to find the torques at each one of those. So basically I'm going to cut it at B, cut it at A. Okay, if I cut it at B, okay, you've got your 4 kilonewton meter force right there, which means to balance that, I have to have in the opposite direction 4, which is going to be the torque at B. Okay, so the torque at B is 4 kilonewton meters. Doing something similar at A, again, you're going to have 4 right here, and then 10 right there. Oops, I gave away the answer there, but you've got 10 going back the other way, which means you have to have 6 balancing it in this direction. So the torque at A is going to be 6 drawn in that direction. Okay, so for the torque at B, or I should say the shear stress at B, it's going to be the torque at B, which again is 4,000 Newton meters, times the distance away from the center, which is 75 millimeters, all over the polar moment of inertia for a solid shaft, which is pi over 2 times the radius to the 4th. Okay, so plugging all that in, I can find that the stress of this guy, the shear stress of this guy, is 6.004 megapascals. Okay, doing the same thing for A. So to find the shear stress at A, again, it's going to be the torque at A times the distance away from the center over the polar moment of inertia. So the torque at A is 6,000 Newton meters. Okay, the distance away, this one's not at the edge, it's only at 50 millimeters, so it's going to be 0.05. But the polar moment of inertia will be identical. Okay, it's the same cross-sectional area, so it's just going to be pi over 2 times 0.75. That's still the radius of this guy. 75 to the 4th. Plugging all that in, and I find out that I get the exact same answer, which is 6.04 megapascals. Now, I should state that this is just magnitudes of this. These are going to be in opposite directions. Okay, right? T to the 4th is in one direction. I'm sorry, T to the 4th. TB, the torque at B, is in one direction, the torque at A is in the other direction. So they'll be in opposite rotational directions, and in fact, it could be up, anyway. Just recognize that this is just absolute values, just magnitudes that we're looking at right here.